In this video, we will see the functioning of waste-to-energy plants, incinerators which convert heat generated by burning waste into new energy that can be used to heat houses and to produce electricity. The raw material is the non-recyclable dry waste, also known as mixed waste, namely all that rubbish we produce every day and that cannot be recycled. Rather than disposing of it in a landfill, trucks take it to the waste-to-energy plant, where it is weighed and dumped in a large pit. Tons of waste get mixed at this point, so that the various loads can be sent to burn in the incinerator have more or less the same heating value. An overhead crane with a hydraulic bucket activated by the plant employee allows the operation to finally put the waste inside of the feeding hoppers of the furnaces. Here, movable grids allow the continuous advancement of waste during incineration. Some air is forced in to provide the necessary oxygen to enable self-combustion. This way, it can be regulated and a constant temperature can be kept. The burning reaches temperatures around 1000 degrees Celsius to ensure total incineration of waste and to avoid the creation of hazardous substances. Burning the waste results in fumes that hold precious energy in the form of heat. The two byproducts are bottom ash, which must be disposed of, and pollutant substances in fumes, which must be filtered out. The fumes then pass through a big heat exchanger, a very important process, where the first real energy extraction takes place. Here, a water circuit absorbs the energy of the burning fumes and transforms it into a high-pressure and high-temperature stream, which can be used for two purposes that can coexist in a single plant. It can either be sent to a steam turbine to produce mechanical energy, which in turn, by means of a generator, produces electric power that, thanks to the transformers, is fed into the power grid. Or, thanks to a second heat exchanger, it can be converted to a heat transfer fluid, which brings heat in a district heating system, so that several houses can use it in heating systems, cooling systems, or for various other purposes. In these two ways, waste gets valued and transformed into new energy, thanks to the waste-to-energy plant. But where does the production waste end up, namely the bottom ashes and the fumes? Bottom ashes, once out of the incinerator, are cooled and transported by trucks to recycling plants, to be used, for example, in road pavement or construction. The fumes instead undergo a purification process consisting of specific filters, which may vary based on the plant type, that must comply with legal limits and therefore be consistently monitored and checked. The most modern system poses 4 different types of purification. The first step is in the electrostatic precipitator, which creates an electrostatic field that withholds the largest ashes and lets only the gases proceed. The second step is in the spray dryer, where calcium hydroxide and sodium bicarbonate are introduced to neutralize acidic gases, and also activated carbon to reduce emissions of heavy metals, furans, and dioxins. Fumes then pass into the baghouse filter, which holds back, through fabric filtration, the dust generated by chemical reactions with the spray dryer. A catalytic reactor then reacts with ammonia and urea to break down the last pollutants, such as nitrogen oxides. All residues from these processes are then collected and disposed of. At this point, purification fumes are sucked in by an induction fan and pushed towards the chimney, a large structure provided with gas monitoring sensors, which are analyzed continuously to keep the plant's atmospheric emissions under control. With this process, waste-to-energy plants are at this time the best solution to solve waste management. First, because the volume of undifferentiated waste, which would end up in a dump site, is reduced by tens of times. And second, because they are also a precious source of energy, that we would otherwise obtain mainly by burning fossil fuels, namely natural gas, coal, and oil. If you found this video useful, let us know by leaving a like and a comment. Moreover, you can share it, and don't forget to subscribe to our channel. We advise you to visit our website, jaescompany.com, to get to know our next projects.